So the first thing that I noticed about number 19 is that it's not quite in slope-intercept form. It's almost in slope-intercept form, but not quite. That 3 needs to get moved over to the other side. I know that you guys know in order to make that happen, I'm simply going to add 3 to both sides. So then in slope-intercept form, this inequality is now y is greater than negative 2x plus 1. So I'm going to start off with the intercept, which is a 1. And then my slope is negative 2 over 1, which means that I'm going to go down 2 and over 1 for my slope. So down 2 over 1, of course. And then I'm going to go down 2 and over 1 again. Now I need to make the decision about whether my line is going to be solid or whether it's going to be dotted. Is it going to be solid or dotted?
Dotted.
Dotted because there's no equal to symbol, right? I'm going to do the best I can to make a decent one. Make sure it goes all the way across the graph. Make sure it has arrows on either side. Now I need to decide, am I going to shade up or am I going to shade down? So if I look at my inequality, y is greater than the line. All of the numbers on the y-axis that are bigger, of course, are up. So that means that I'm going to shade upwards. So in other words, all the possible solutions for that inequality are in this shaded region. I could pick any ordered pair in that shaded region, and it would be a possible solution to that inequality. So I believe I just answered that question. Okay, so would any ordered pair above the line be a solution? Yes. How do you know? This is your study guide. Whatever makes sense to you. I would just say something along the lines of the coordinates above the line are shaded, something like that.
Yeah, I just picked one just because it's shaded.
That's fine with me. This is your study guide, so basically, how do you know? Because of the shading, because that's where the shading is, right? Oh, I said it wrong as I was writing it. Whoops. Coordinates above the line are shaded. Would any ordered pair on the line be a solution? Yes, sir.
No.
Why not?
Because it doesn't say equal or greater.
Beautiful. So no, in this case, it would not. And if you just write dotted line, that's good enough for me because we all know what that means, right? If the ordered pair is on a dotted line, it is not a solution, in case you can't tell. That's going to be a question that everybody misses every year. So we're trying really hard to make sure that you're not that person that misses it tomorrow. Okay, number 2, same deal. Number 20, I'm sorry. I need to get this one into slope-intercept form the same way I did the other. All I got to do is a quick little add 2 to both sides to get the y isolated. So I've got negative 1/5 x plus 2. So if I'm going to graph it slope-intercept style, I'm going to start with that y-intercept of 2. My slope is negative 1/5, so I'll go down 1 over 1, 2, 3, 4, and 5. I ran out of room, so of course I need to go back in the other direction, up 1, 1, 2, 3, 4, and 5. Solid line or dotted line?
Solid.
Solid. How come?
Because it's not equal to.
Because it is equal to, right? Yeah,
Sorry.
I knew that's what you meant. Because it is equal to. And, I just broke the cardinal rule of inequalities. I accidentally turned that into an equals. Ruh-roh. So now y is greater or equal to, so once again, we are going to shade up. Would any ordered pair above the line be a solution? Once again, that would be a yes. I know that because of the shading. Again, I don't need you to write me a novel. I understand what that means. I do want you to have to explain your thinking, but I don't want you to write more than you have to. And would any ordered pair on the line be a solution this time? Yes, it would. Yes, because it's a solid line. Good.
Those are going to mix me up, like which one's solid and which one's not.
There is all kinds of extra practice on Google Classroom, guys. Like I have, yeah. It's different. You're going to do this to death in algebra too. Like you're going to do something called linear programming. This is really cool because it's like very real life, like when you actually really use this stuff.
Yeah.
And you're going to do this a lot. So the other two, personally, number 21, I would graph by intercepts because I see that the 5 and the 2 very easily divide into the 10. If you choose to switch it into slope-intercept
that
form,
way
though,
better.
then you do you, girl. Whatever works for you. As long as you get the right answer, I couldn't care less. I'm going to graph it by intercepts because I can sit here in my head and I can think to myself, okay, well, negative 10 divided by 5 means that my x-intercept is going to be a negative 2. And then I can do 10 divided by 2 to see that my y-intercept will be a negative 5. That's just easy for me to do. So that's what I'm going to do. But if you want to convert it, lots of my best students just convert it because that's just what they want to do. That's fine. Obviously, I'm going to do a solid line. Oops. Solid because it isn't, that was not a good solid line at all, was it? I only need 2 coordinates because I graphed it by intercepts. Now, the only thing about doing it by intercepts is, of course, you don't get the nice little is y greater than or less than to decide whether to shade up or down. Instead, you have to use a test point in order to make that happen. So what's the easiest number on earth to do math with? That would be 0. So I'm going to use the origin as my test point. Bless you. So I'm going to substitute 0 in for x and y. 5 times 0 will obviously be 0. 2 times 0 will obviously be 0. 0 plus 0, is it greater than or equal to negative 10? Yes, it is. Lots of people get that wrong because they're like, oh, 0's not greater than 10 because they don't realize that's a negative 10. 0 is greater than negative 10. So that means that 0, 0, the origin, is a potential solution. And if 0, 0 is a solution, then that means that every coordinate on that side is, in fact, a solution. So that's another good reason that you might want to always convert them, because then you can use that trick very easily. Do I shade up or down? So that's actually a good reason to do it your way. Number 22, I'm probably going to go ahead and convert this one because those negatives make me nervous. So I'm going to move that x over to the other side. I'm going to do that by subtracting x, of course, from both sides. So I'm left with a negative y is less than negative x minus 4. I have to divide everything by negative 1 to get that y isolated. And what happens when I divide everything by negative 1? I have to flip the signs of everything, but I also have to flip the little symbol. Yeah. I see hand gestures, so I know what we're talking about. Okay, I got to flip the symbol also. That's going to make a difference when I decide which direction I'm going to shade in. So that's a very common boo-boo. Make sure, I can almost guarantee you there will be a negative y in there. Very, very common boo-boo. If you had to divide by a negative, and even just to convert it, you still got to flip the symbol. So my y-intercept is a 4. Of course, my slope is a 1, so I'm going to go up 1 over 1. Like so. And it's going to be a dotted line because there's no equal, so I'm just going to add arrows to these dots. I know that looks really awesome. Okay, and my y is greater than my x plus 4, so the greater numbers are up. I've got lots of greater thans in here. It's not normally like that all the time.
Yeah.
Which means I need to shade upwards. Okay, so that'll be graphing. Are we all good? Any questions? Fantastic. Okay.
We can go over all of them.
We're going to go over these 4. We're going over the ones the graphing ones. Okay, so now we're going to go over number 23. I'm going to do this a little more quickly. So one of them is in slope-intercept form. The other one is not. It doesn't divide nice and easily. That 3 and 2 don't divide nice and easily into the negative 2. So I am going to go ahead and convert it. I'm going to convert it. So I'm going to scoot it over here. So I'm going to subtract 3x from both sides. Got 2y is less than or equal to negative 3x plus 2. And then, of course, I need to divide everything by 2 in order to get the y isolated. So y is less than or equal. Remember, that's your slope. So negative 3 over 2x. And then that 2 over 2 simplifies to just a 1. So that's all linear equation stuff from our previous unit. So all I did was just scoot. Oh, shoot. You know what I didn't do? What did I forget to do? Did y'all notice what I forgot to do? Or what I messed up?
Oh, flip the sign. on
No,
The negative one.
Yeah, there's a negative with that 2.
So it's a minus 1. Okay. Because that's what I.
Yeah.
So that's why I was
Oopsie.
like-
Yeah, so it should be a negative 1. Sorry, guys.
You're fine.
At least that better late than never, I
Makes more
noticed.
sense now, 'cause
Yeah.
I was confused.
All right, well, I'm glad. Sorry about that. All right, so we got our negative 1. So now they're both in slope-intercept form. I'm going to graph this one first. So my y-intercept is right here at negative 1. My slope is negative 3 over 2. So I'm going to go down 3 and over 2. Need a solid line, of course, because it's an equal to. Now I'm going to go back and graph the one at the top that was already in slope-intercept form. I'm going to use a different color. Even though I recommend tomorrow, it's hard to fix mistakes if you use color. I'm doing it for the visual, but you probably don't want to do this tomorrow. So my y-intercept is 3. My slope is 1/2, so I'm going up 1 over 2. And this one is simply going to be connected with a dotted line. Basically, the way the systems problem will work is it'll be like one problem will be worth a lot of points because there's a lot to do here, right? You got to actually graph the line correctly. You got to decide whether it's shaded or whether it's solid or dotted. And then you have to decide what direction it gets shaded in, all in that one problem. So it's going to be worth quite a few points for this one. So lots of little decisions that you got to make. So once I've got them graphed, now I'm going to go through and decide whether I need to shade up or down. This one, my green, y is smaller than negative 3x minus 1. So that means I'm going to color down. I'm going to shade downwards. And then my blue one, y is also smaller than 1/2 x. So that one is also going to be shaded down. So the solution to that system is that area right here where they overlap, where you see both the green and the blue.
So you said we didn't have to write anything?
You do not need to write anything because I, as the teacher, will look at it and see, oh, those are their solutions. What would make it easier for me, guys, is if you did take the extra step and kind of darken it the way that I did, just so that it's very obvious to me. On some of your alls that I was looking at, it was kind of hard to tell exactly where it overlapped. So if you could do that little extra step, it'll make it a little easier for me. Okay, number 24. I would probably go ahead and convert this one to slope-intercept because it's pretty easy. So I would subtract x from both sides. That's going to leave me with a 3y is less than negative x minus 6. And then I need to divide everything by 3. No negatives this time. So my slope here is going to be negative 1 divided by 3 x. And then negative 6 divided by 3 is minus 2. And then we'll deal with that x1 in a second. So this is in slope-intercept form. So now I'm going to graph my negative 2. My slope is down 1 over 3. I'm going to connect it with a dotted line. And I'm going to go ahead and shade it. Y is smaller than negative 1/3 x minus 2. So smaller numbers are down here. And then x, anytime you've got just an x, that x is greater than 3. Remember, that's going to be a vertical line that is just going to go through the 3. And x is greater than 3. All the numbers that are greater, bless you, are over in that direction. So our solution where they overlap are is that little space right there. Again, it would help me if you would darken it a little bit for me. It would make it easier for me to grade. Last two, I really do appreciate your all's patience and attention. I know study guide days suck, but they're kind of necessary. Okay, so both of these, at least we don't need to convert. So x is less than 1. It's just going to be a vertical line going through the 1, if I can draw a vertical line. Okay, so I'm going to draw the vertical line first. And then y is greater than negative x plus 2. I'm going to start at that y-intercept of 2. And then it's, oh, what do I need to change about my line, guys? It's not dotted. Ruh-roh. I'm doing it on purpose just to give you all the warnings of all the little places you could go wrong. Isn't that nice of me?
Yeah.
I'm looking out for you.
Very nice.
Oh, shoot. I did it up there, too. I know. I'm so sorry, guys. Just write the word dotted up there by that green. Did the same thing there. I'm sorry. All right. So now I got a positive 2. Where my y-intercept is. And then my slope is a negative 1, so I'm going down and over, down and over. This time I'm not going to screw up and use a solid line when I should be using a dotted. For the yellow, x is smaller than 1, so all the numbers that are smaller than 1 are that way. And then for the blue, y is greater than negative x minus 2, so that means we got to color up. So the sweet spot, the solutions to those two inequalities is right there where they overlap. Last one. So y, I'm going to do that one first, just because the vertical or horizontal line just seems easier to me. So when it's a y and nothing else, that has a slope of 0. So it's going to be a dotted line that goes straight through the negative 3. It says that y is smaller than negative 3, so that means we're going to shade down. Don't forget to add my arrows. And y is greater than or equal to negative 4/3 x plus 1. So I've got my y-intercept of 1, and then down 4 over 3. Up 1, 2, 3, 4 over 3. Solid. And y is greater than or equal to the rest of the line. So we are going to shade above. So the solution to those two inequalities is going to be that teeny tiny little region down there where you have both of them. See how little that is? So make sure you got that nice and dark.
This part wasn't that hard.
No, it's,
The other
yeah,
one was harder.
there's a lot of places in a system, there's a whole lot of places you can make a mistake.
But it's easier.
But it's not that difficult. You just have to double check yourself. Like, don't do what double check and be like, ah, crap, I didn't dot that or whatever. So they're worth a lot of points because there are a lot of steps. But the steps individually are not that difficult. Okay, the only thing I do want to add is over here. You guys had some word problems that were given out to you when you were in class. We've done several of these. I'm going to post the key for it's like these 4 word problems, and the game we're getting ready to play, I'll have a couple word problems too. But I just want to point out to you that go and make sure that you look at the key for the word problems you were given in class for extra practice. And then last thing, I'm going to take questions. Is there anything on the individual, on the stat? A lot of people whose intercepts were not correct, and several people whose line wasn't correct. So I want to make sure you understand, because again, the word problem on your test is so similar to this. So I want to make sure I take the time to go over it. So it says the basketball game costs $3 for students and $6 for others. and that the basketball team hopes to make more than $300. Okay, so if we use X for student cost and Y for others, then the inequality would be $3 per student plus $6 for others. Here's where we went wrong first. Does this say at least 300? It specifically says more than. So there is no equal to. Look right now and see. Did you put an equal to sign in there? If you did, it's not correct. There should not be an equal to sign because it says more than 300. If you have an equal to sign there, it should not be there. Then it said to graph the inequality. Lots of people had issues with the intercepts. Figure out how much your x-intercept and your y-intercepts are going to go up to. Like how far on your graph you need them to go. So because you could do 300 divided by 3 to get your x-intercept, you know that your x-intercept is going to be $100 if you sold nothing but student tickets. To get that $300, you'd have to do 300 divided by $3 a ticket. You would have to sell $100 a ticket. To get your y-intercept, if you sold nothing but tickets to other people, 300 divided by 6 means you would have to sell 50 tickets. Some people had 3 and 6 graphed on there. That's not what that means. It means how many tickets would you need to sell if all you sold was student tickets. Okay, you would have to sell 100. If all you sold were other people tickets, you would need to sell 50. So that is what your intercept should be. So my x-intercept, I'm not going to spend time on the scale and stuff right now just because of time. So your x-intercept should have been over here at 100. Your y-intercept should have been at 50. You should not have had a solid line because that was not an equal to situation. So those were the issues that most people had right there. It was the intercept wasn't right, or the line was solid when it should have been dotted. And because they want to make more than $300, we know that we need to shade up. That part we did correctly. It was the rest of it where we really struggled. Guide. Just on the regular, the ones that you guys already did. Like you put it in there, you're just not sure what you did wrong.
Will you post more extra practice problems of these? Because that's advantage.
Okay, I'm going to post extra multi-step and extra compound. There's also, if the interval notation is the problem that you have,